It's a pleasure welcoming you all for my mathematics section, and I'm continuing with Fourier problems in Fourier transforms. I have already taught what is a Fourier transform, some of the properties, and a problem has also been done. Today I am continuing with Fourier transforms. Here I have written one of the properties of Fourier transform, which is very important from the examination point of view, and this is normally asked in university examinations, sometimes in A part and sometimes in B part of this problem, and also this is a second problem is very important. This is frequently asked in university examinations. I'll try to be slow and explain as much as possible. If you closely watch the video and follow me carefully, I am 100% sure that the students who are watching this will definitely benefit and will improve their knowledge and score good marks in their university examinations. With this, let me start explaining you the problem. Now, I'll go straight into the problem, so that because I have explained enough in my previous videos. You go through my videos, every step will be explained. So I don't leave even a step. Step by step I give explanation. So let me go into this. Now what is given here? So I will take this very simple and straightforward. I will tell you I will tell you the places where you have to concentrate and keep the things in memory, so that you can do the problem well. See here, you see that. See, first thing is the Fourier. See, I'll write here the Fourier transform of any function is. See, if you are given any, see, you must know that there is one thing called Fourier series. Fourier series is the one which you can find that the function will be defined in an interval. But here the function is completely from minus infinity to plus infinity. But the condition is also there that because the function f of x must qualify certain conditions for some conditions. Here, finite number of minimum, finite number of discontinuities. If these properties are there, then we can develop as a Fourier transform. But in the case of Fourier series, here there is it has to satisfy, the function has to satisfy the Dirichlet conditions, and that it will be defined over an interval. But this is not so here. Now, so the Fourier transform of any function, I'll write here, any function f of x is given. If it is given, see, how will you write this? This you write it as f of x. Say this is how you write, or this will be f of s, that is equal to 1 by square root of 2 pi minus infinity to plus infinity f of x e to the power of I s x into dx. Call this as 1. So this is very important. This is the Fourier transform of a function f of x, and if this is given, see, if this is f of s, why I put here f of s? Because if you solve this in the sense that if you integrate, on integration of this, you will get this, you will get it as a function of s. What I mean is that you get the integration of this, you do this integration, the integration will be purely in terms of s, and therefore this is f of s is given. Now if f of s is given, see, you see that if f of x is equal to f of s, this is given, then you see that f minus 1 of f of s will be equal to your f of x. So you see that once you are able to find the Fourier transform of a function f of x, then you can get the inverse Fourier transform, which is nothing but f minus 1 of f of s is equal to f of x. This is called your inverse Fourier transform. And the inverse Fourier transform formula is 1 by square root of 2 pi. It is minus infinity to plus infinity. It is f of s e to the power of, it is minus isx into ds. Now you see that, so you see that once if you integrate this, you will get it as a function of x. You integrate this, get the value of this integration. You see that this on integration gives a function, a value which is a function of x. So you see that these two are called Fourier transform pairs. It is called a FT pairs. FT pairs. So these are called FT pairs. Now let me not elaborate much because I have taught enough. So this is what we have got here. So you see that here take f of x is equal to cos x into f of x. So what is that you are given here? Take in the place of f of x cos ax into f of x. Then what is that you will get? F into cos ax f of x is equal to, so simply substitute 2 pi into minus infinity to plus infinity. In the place of f of x, you must write it as f of x into cos ax into e to the power of isx into dx. So I have not done anything except replacing this f of x by f of x into cos ax. So I will do something here. You just understand what I do here. So this I am retaining as it is. It is this, and this is cos f of x into this can be written as e to the power of iax plus e to the power of minus iax divided by 2 into, you retain this as e to the power of isx into dx. Because we know that e to the power of c, it is nothing but e to the power of I theta plus e to the power of minus I theta divided by 2 will be equal to your cos theta plus I sin theta plus cos theta minus I sin theta whole divided by 2. So this is nothing but your, see, 2 cos, it will be cos theta. Because you see that this will be e to the power of I theta plus e to the power of minus I theta, de Moivre's theorem, plus I sin theta minus I sin theta will giving you what? 2 cos theta. 2 divided by 2 is 2 and 2 goes off giving you cos theta. So you see that this cos ax is nothing but this. So in the theta, in the place of theta you have got sx. So you can write this as, in the place of this ax, so I can write it as cos e to the power of iax minus plus this, and you will get. Now you see that this can be written as, I want space, so I am writing here. So RHS, so this is your LHS. So this is what you have. See, this is, I will write here. This is nothing but, I will write this as 1 by 2 pi square root of this. It is minus infinity to plus infinity. It is f of x into, see, you see that this is e to the power of, I'll take this half outside, e to the power of, see, you see that this isx and this iax and isx, if you multiply, you will get this as e to the power of I s plus e of x into dx, and plus you take this 1 by square root of 2 pi, it is minus infinity to plus infinity, it is f of x into e to the power of I, see, it is I into s minus a of x dx. So this is what you will get. See, I have not done anything except the algebraic simplification. That is algebraic, I multiply, nothing but. So you see that this is f of x, e to the power of iax into this will be what? E to the power of iax plus isx. So I am taking this I outside and s plus e into x. I am keeping this as one integral plus 1 by the square root of 2 pi. Then f of x, this is minus iax, this is plus isx. So you see that my isx is coming here. So I have not done anything except multiplication. It is what using theory of indices. A to the power of m into a to the power of n is a to the power of m plus n. So I am using this idea. Now immediately you can write this. So I will explain this. So this is half into. So you see that here you can watch one thing. F of x is equal to f of s. This is the definition of a Fourier transform. Now if it is yes here, then here it is must be yes. See, whatever you see here, f of yes means here you see that this is yes. So you identify these two in the same lines, so you will find that this looks same as this, except for the difference that here you have got s plus a, here you have got s, and likewise here it is s minus a, here you have got s. So in the place, the only difference between this definition of Fourier transform and the one that we have arrived is that in this place it is s and it is s plus a, and here it is s and here it is s minus a. So you can very logically write this as, because this is a Fourier transform. This is a Fourier transform of f of x into, see, this is a Fourier transform, and here you find that this is s plus a, so this is nothing but your f of s plus a plus f of s minus a. So this is all about your this is. So I have proved this. So I have not done anything except that I have applied this Fourier transform on this function, and I have used the idea that this cos ax can be written in that form. This is the form that you can write. Split it into two integrals. Identify this with this, you will get the answer. So this is all about the problem 1. Let me pause on to the problem 2. So problem 2 is this. I hope that you have understood. If you have still any difficulty in understanding this, you are welcome to write your comments, and I'll definitely reply to that. Okay, thank you. Now let me write this. Now let me start doing the second problem. What is the second problem that I have given? The second problem is this. The second problem is, say you are given this function. And you are given this function and you are asked to find the Fourier transform of this. Before doing this, I will explain what is the meaning of this. F of x is taking the value 1 minus x squared in the interval. Do you know what is the meaning of this? It is minus x is also equal to 1 and plus is x is equal. So x is equal to minus 1, x is equal to plus 1. So you see that this is x is equal to minus 1. So this means that minus 1 less than or equal to x less than 1. That means what? X will take the value at the least minus 1 and it can take also the plus 1, and that it will be like this. So you have got like this. It is minus 1 plus 1, and what is the meaning of this? See, modulus of x greater than 1 means minus x is greater than 1 and x is also greater than 1. So the meaning of this is, it is x is less than minus 1 and x is greater than 1. That means what? Here this means this is a domain. See, this is the area which is x is less than 1 and this is the area where x is greater than 1. What does this mean? So this function is not, it is equal to 0 in this domain and it is 0 in this domain, and it has got value only the 1 minus x squared between minus 1 and plus 1. If you put x is equal to half, 1 by 4, 3 by 4 will be that. That means if you put x is equal to half somewhere, if you give x is equal to half, or here whether it is plus half or minus half, your value of y will be equal to what? 3 by 4, like this. So this is a function that lies between minus 1 and plus 1, and you must know that this, after all, this minus 1 and plus 1 is a subset of the whole of minus infinity to plus infinity. So they have this in your mind. Now I hope that you have understood this. So let me pause on to this. So what is the meaning of this? So I will write this. So this is what you get here. See here. So given f of x is equal to 1 minus x squared minus 1 less than or equal to x less than or equal to 1, and is equal to 0 for x greater than 1 and x less than minus 1. So this is all about. That means it is defined only in this interval and nowhere else. Okay. Now let me take in this way. Now we know that. See, let me find Fourier transform of f of x. We know that f of x, we know that f of x, which is equal to f of s, is equal to 1 by square root of 2 pi minus infinity to plus infinity, and is your f of x into e to the power of I s x into dx. So this is the definition of a Fourier transform. Now applying here now. So you apply this f of x. Take this f of x. So what is that you will get here? 1 by square root of 2 pi. It is minus infinity to plus. So if it is minus infinity to plus infinity, now you see that this will become as what? Minus 1 to plus 1, because beyond that, less than minus 1, greater than 1, it becomes 0. So it is defined only as interval. So it is minus 1 to plus 1, and it is, and what is the function? 1 minus x squared into e to the power of isx into dx. So this is what you will get. So I will write this as, see, immediately you can write this. It is 1 by square root of 2 pi. It is minus 1 to plus 1, 1 minus x squared into cos sx plus I sin sx. So this is what you will get, and you can split it into two integrals, as this can be written as 1 by square root of 2 pi. It is minus 1 to plus 1. It is 1 minus x squared into cos sx into dx plus 1 by square root of 2 pi minus 1 to plus 1 1 minus x squared into sine sx dx. So this is what you will get. Now let us start analyzing this. I will take this. See, I will rub off this afterwards. Let your phi of x be equal to 1 minus x squared into cos x. You take this. Then phi of minus x. What is phi of minus x? Wherever x comes, you put it as minus x. So this is minus x whole squared. So this will remain as it is. 1 minus, say I will write this if you want. It is 1 minus x whole squared into cos s of minus x. So this will be equal to what? It is again 1 minus x squared. Cos of minus theta is cos theta. So cos of sx. So you see that phi of x is equal to so much. Phi of minus x also equal to so much. This implies that phi of x is equal to phi of minus x. This implies phi of x is even. And like that, let us take this to be what? Xi of x. What's there? Let xi of x be equal to 1 minus x into sine sx. Then xi of minus x will be equal to, as it is 1 minus s squared into sine s of minus x. Sine of minus theta is minus sin theta. So this is 1 minus x squared into sine sx, and this will be equal to minus sine of x. So this implies psi of minus x is equal to minus psi of x. This implies psi of x is odd. So psi of x is odd, and I told you that if it is, I have taught many a time in my lessons, in my classes, that if it is an even function, this will not become 0, but if it is an odd function, this will become 0. So you see that this will become 0. So this will become 0, and this, so that what does it mean? In this integral, this will be 0 and this one only will be there. So that is, it will only survive, but the other one will be what? 0. So in this whole of this place, I can just retain only that integral. I hope that you are able to understand. Let me rub off this place for want of space, and I will write the, I will continue doing it. So I will rub off this. So what is that you will get here? So in this place, so this is 0. So for what reasons it becomes 0, you must know. Every step is very, very important. So you see that this is nothing but 1 by 2 pi into minus 1 to plus 1 minus 1 minus x squared into cos sx into dx. But I have taught you also another thing, that if it is minus 1 to plus 1, using the property of definite integrals, what is that I can write here? 1 by square root of 2 pi into 2 into 0 to 1 1 minus x squared into cos x into ds, using property of definite integrals. So using the property of the definite integrals, I am able to get this. Now I'll continue with the problem here. So I'll write it here. So what is that you will get here? So your f of s is equal to, I'll rewrite this. See, 2 divided by this, so you will get this 2 by pi. Square root of this and this will go off, giving you 0 to 1 1 minus x squared into cos sx into dx. So this is what you will get here. Now let me integrate and get the values. Now it is your using Bernoulli's method of integration. What is that I will use? So so you can write this as 2 by pi square root of that. Then use the Bernoulli's method of integration. This is nothing but, I will write this step also. So this is nothing but 2 by pi square root of this. It is 0 to 1 1 minus x squared into differential of sine sx divided by s. Now you see that I have written this. If you take the differential, you will get again cos sx. So you take this as your u and take this as your v1. Now what is your uv1? 1 minus x squared into sine sx by s. Keep this in a bracket. Minus, open a bracket. Differentiate this. Differentiation of 1 is 0. It is minus 2x into, integrate this. Integration of sine sx is minus cos sx. Minus cos sx divided by s. S into s is s squared. Keep this in a bracket. Then I will write this afterwards because I want space. So I will rub off everything here. So what is that you will get here? So plus, see, plus, minus, plus, and this is in the differentiation of minus 2x is minus 2 into the integration of cos x is sin x. So into minus sin sx divided by, this is s cubed because that will come as s cubed. Close this bracket and apply everything 0 to 1, 0 to 1, 0 to 1. Okay. Now this is what you get here. So this is 2 by pi. It is, now if you put x is equal to 1, 1 minus 1 is 0. And if you apply the second limit, lower limit, sin 0 is 0, so the whole becomes 0. I'll repeat this place. I will repeat this place here. So you see that if you start applying the limits, first upper limit, then minus the lower limit. Apply the upper limit, it is 1. X squared is 1, 1 minus 1 is 0. As per the first limit, if you apply, it becomes 0. If you apply the second limit, sin 0 will become 0. So in both the cases, the terms become 0. So the whole thing becomes 0. Forget it. Then here you see that here if you apply 1 here, it is minus 2. So let me write here. So minus into minus plus into minus. I will rewrite this minus. It is 2x into cos sx, 2x into cos sx divided by s squared. Then apply 0 to 1. See, minus into minus is plus, already minus. So 2x into cos sx divided by s squared. Then this is minus into minus is plus, and you write it as 2 sin sx divided by s cubed. Apply 0 to 1 again. So what is that you will get here? So if you apply 1, it is 2 cos, if you put x is equal to 1, it is 1. So it is yes. So this is nothing but 2 by pi square root of this into, you apply the first limit, it is minus of, it is 2 cos s divided by s squared minus, if you apply the second limit, 2 into 0 will be 0. So it becomes 0. So let me put it as 0. Okay. Plus, you apply the first limit here. You apply the first limit, it is 2 sin. It is 2 sin s divided by s cubed. And if you apply the second limit, sin 0 is 0. So don't worry about that. So you will get it as this. So what are you left with now? So this is 2 by pi square root of that inside the bracket. Now you take this minus sign inside. So minus 2 cos s by s squared plus 2 sin s by s cubed. So I can rewrite this as 2 by pi square root of this. Take this 2 also outside, no problem. Take this 2 outside and write the remaining. Take this. So it is sin s by s cubed minus cos s by s squared. So you are getting this now. You take this square and take it inside, it will be 4. So it is 8. 8 by pi into, this one take the LCM, so you will get this as sin s minus s cos s divided by s cubed. So this is what you get. Now you see that there is something here given. See, can you see this? We are able to get this answer. See, I am getting sin s minus s cos s divided by s cubed. So I am able to get the answer. So what is that f of s now? So f of s has been finally got as f of s. This is the answer. So this is the Fourier transform of, so that f of x, when you apply the Fourier transform, it will be taking a form of this in the S plane. Are you able to understand what I am talking? Yes, Fs plane, it will be like that. So this is my answer for the first one. So my answer for this is, I'll write here. So the Fourier transform of that is f of s. So what do you get here? It is 8 over 8 by pi square root of that. And it is sin s cos s divided by s cubed, and this is the one. So sin s minus s. So this is my answer for the first part of the question, namely find the Fourier transform. So this Fourier transform has been found. Now what is that here? It is not, see here it is this Fourier transform. Find the Fourier transform of this has been found. Now let me prove the what? Let me prove the second part. What is that second part you have got here? It is 3 pi by 16. So this is what I am going to do. Okay. Now let me start doing this. So here you see that what does it mean? You're finding the integral value of this Fourier transform. Say this is the Fourier transform of f of x. Now you're going to get the value of that. You're going to get the value of that using the inverse Fourier transform. Are you able to get? So I will write here. Let us apply. I'll write here. Let us apply the inverse Fourier transform to prove, you call this as your 1. Let's apply inverse Fourier transform on f of s to get 1. So you must be very clear of what you are doing. Step by step, logically if you go, you will arrive at the answer. So you see that let us apply inverse Fourier transform on f of s to get 1. Now we know that. Now what is the form of a inverse Fourier transform? F minus 1 of f of s. This is nothing but your f of x, and the formula is given by 1 by 2 pi into integral of, again minus infinity, in that plane also minus infinity to plus infinity. It is f of x e to the power of minus isx into ds. Now you must know that this is a Fourier. I told you that these two are f of x and f minus 1 of f of s. They are called Fourier pairs, and you must know that there the formula, and this formula is also not unique. It is not unique. In some of the books, this 1 by 2 pi square root of 2 pi will not be there, and in some of the books here it may be e to the power of isx. In the Fourier trans it may be e to the power of minus isx. In all cases you will get the answer, but you must know that you must stick on to one way of doing it, otherwise you will get confused. So stick on to my way of doing it or the other way, but do not write the wrong one. You will not get the answer. So this is a way I have taken e to the power of isx there. Here I am taking it as minus isx, and I am multiplying this integral by 1 by square root of 2 pi. So this you can maintain. Okay. Now this is what I get here. Now, so you have to apply here. So what is that? Therefore I will write it the other way about. Therefore 1 by 2 pi, it is, see, it is integral of minus infinity to plus infinity. What is your f of s? F of s is 8 by square root of pi into sin s minus s cos s divided by s cubed into e to the power of minus isx into ds is equal to f minus 1 of f of s, which is equal to your f of x. So this is because naturally you must get your f of x. You will get your f of x, and then you see that is bring this 8 by pi outside. So 8 by square root of this into 1 by square root of 2 pi into minus infinity to plus infinity. It is sin s minus s cos s divided by s cube into, again this is cos sx minus I sin sx into ds is equal to f of x. Now you see that and understand that this f of x you are getting it is again defined only in this interval -1 to +1 only. It is defined only in all other regions. This is also going to be 0. This is also, so you see that this will be defined only in that particular integral. So in interval. So you see that accordingly we will fix up the values. Accordingly we will get the value of x. Okay. Now, so this is what. Now let us analyze. Let us start. I will not go deep into that because I have explained enough. Now you see that this can be split into two integrals. If you want, I can go for, see, this is square root of 2. This is 2. Here, what is 8? 8 is 2 root 2. I'll write this. See, what is this? 2 root 2 divided by square root of pi into 1 by square root of 2 into square root of pi into minus infinity to plus infinity. Then you see that this can be written as sin s minus s cos s divided by s cube into cos sx. I'll write fully like this. And it is ds. And it is integral of minus infinity to plus infinity sin s minus s cos s divided by s cubed, and keep this in a bracket, and it is I is there. It is I, you can take it outside because after all it is minus square root of -1. So it is sin sx, this is what you get, is equal to your f of x. So this is, so I have split this into two integrals. Now you see that this root 2 and root 2 will go off. This pi, square root of pi into square root of pi will be pi. So what is that you get here now? I'll write it here. So that is, see, it is 2 by pi. 2 by pi, see, this is 2 by pi into integral of minus infinity to plus infinity. Let us analyze this. Let us analyze. Function here dx is that. Sin dx is equal to f of x. So you see that this is odd, this is an even function, this is an odd function, even into odd is odd. This is an even function, this is also an even function, even it is even. So the value of, when you find the integral value, this will be 0. There is no need to spend labor finding the value of this. Don't do that. That is why we go for finding whether, because you see that it is minus infinity to plus infinity. When you come across minus infinity to plus infinity or minus a to plus a, whatever be it, you try to find out what is the function, whether it is odd or even. If it is even, it will be existing. If it is odd, it will become 0. So that is why I am doing this. So I have found that this is an odd function, the value of it is 0. My labor is reduced, my work is reduced, whereas I have to evaluate this. But I have to prove that this same is equal to something like that. Okay, so this is 0 and this is not 0. It is existing. So what is that you are getting here? So 2 by pi, I'll write here 2 by pi minus infinity to pi of sin s minus s cos s divided by, see, s cos s divided by, it is s cubed. So into, it is cos sx into dx is equal to your f of x. So this is only existing. As I told you, this is even, this is odd, again this is odd, odd by odd is even, even into even is even. So this is over. So this is what we get. Now that is equal to what? So here you see that I am able to get this, and this is equal to, so this value is existing only in modulus of x is equal to 1. So this implies that it is, so now this is an even function. You can write this as 2 by pi into 2, 0 to infinity of sin s minus s cos s divided by s cubed into cos sx into, it is ds, into ds. You must be very careful. ds, here it is ds. So into ds is equal to f of x. into f of x. Now this is what we get. But you see that this value is equal to what? This value is equal to 1 minus x squared in the interval. What? 1 minus x squared. So this is equal to what? 1 minus x squared for modulus of x is equal to 1. That is minus x minus 1 less than or equal to x less than or equal to 1. So it is defined like this, minus 1 plus 1, and it is defined like this, 1 and 1. And you see that what is that we want here? So you see that in this result that you want, what is that you want to prove? You want having here s by 2. Now s by 2 means what? Take this, see this is in this place x, you must have it as half. It is very common, it's nothing big that I am doing here. So it is cos s, so in the place of x I must have half. So you see that this half lies in between minus 0 and 1, it lies, and this is a continuous, the function is continuous in this interval. The function is continuous in the interval, therefore at x is equal to half the value exists. The value of f of x at the point x is equal to half, it exists. Therefore you can very well put what? X is equal to half, because this integral I am saying that this may be defined in whole of this interval 0 to infinity, and you see that in this particular this 0 to 1 also, see it is 0 and 0 to 1 is a subset of 0 to infinity, and that x is equal to half definitely exists. Can you understand? Now this is 0 to infinity, 0 to 1 is after all a subset of it, and x is equal to half is a point of continuity. Now I'll take right here, since x is equal to, take x is equal to half, which is a point of continuity, and f of x is equal to, it is 1 minus 1 by 2 whole to the power of whole square, that is 1 by 4, which is equal to 3 by 4. So at this place what happens here? So at half the value of your f of x will be what? 3 by 4. Now substitute here, what is that you'll get? It is 4 by pi into 0 to infinity. It is sine s minus s cos s divided by s cubed into cos, in the place of x you put half, so half of s into ds is equal to what? In this place you can write it as 3 by 4. So this implies 0 to infinity sine s minus s cos s, cos of s divided by s cubed into cos of cos s by 2, cos s by 2 into ds. Take it to the other side, pi into 3 divided by 4 into 4. So I am getting the answer. So what is the final answer that you will get here now? So in general, so what is that you get? So I am able to prove the result that is 0 to infinity sine s minus s cos s divided by s cubed into cos of s by 2, this is equal to 3 pi by 16. So I have got the answer. So this is an important problem. I will do more problems in different types in the coming days to keep you well for your university examination, and also these things will help you to do better in your core subjects. Thank you.